Hello, welcome student to Praveen Patil College of Diploma Engineering and Technology. Our department is Humanity and Science. Course Basic Mathematics course code 22103. Name of faculty obviously Smita Shekhar Kamble. Our unit is 1, chapter number 4, partial fraction. Partial fraction is most probably depend on the partially distributed linear factor, how it is split up. 6x minus 2 upon x minus 3 into x plus 1. We have to split the partial fraction into two linear factors into partial fraction. Split up the fraction into two linear parts with numerator and capital A and capital B. That means we have to convert the numerator. It is in the form of a upon x minus 3 plus b upon second factor x plus 1. Now we have to take the cross multiplication of these. So capital A into x plus 1 upon x minus 3 into x plus 1. Capital B into x minus 3 x plus 1. Then 6x minus 2 x minus 3 x plus 1 remain as the same. This is the given term. We know that we have to group these. So we know that a plus b upon c, a upon c plus b upon c, a plus c upon what? No. A plus b upon c is a, no. Which is applicable? Yes. A upon b plus c upon b is a plus c upon b. That's why a in capital A into x plus 1 plus capital B into x minus 3 upon x minus 3 into x plus 1. Now 6x minus 2, x minus 3 and x plus 1 remain as the same. That means these have the same denominator as the initial fraction. So the numerator must be same. So we have to cancel the denominator and numerator same. 6x minus 2 remain here in a left hand side and in a right hand side. Capital A in bracket x plus 1 plus capital B in bracket x minus 3. So we have to find the first factor. So or second factor, it is not totally depend. Just we take the x plus 1 first. We have to put x plus 1 equal to 0. That means x equal to minus 1. So if x equal to minus 1, instead of these left hand side and right hand side, we have to put x equal to minus 1. So 6 into minus 1 minus 2. So 6 into minus 1 is minus 6. Minus 6 minus 2 is minus 8. Capital A minus 1 plus 1 minus 1 plus 1 gives value 0. 0 into A is 0. Plus b remain as the same. Minus 1 minus 3. But minus 1 minus 3 is minus 4. Minus 4 into b minus 4b. We derive minus 8 equal to minus 4b. Minus 4 is multiple. So divide this side. So minus 8 upon minus 4. 4 2s are 8. Minus minus get cancelled. We derive the 2 is equal to b. Now our second factor is remaining. What is that? Yes, x minus 3. So we have to put x minus 3 is equal to 0. So x equal to plus 3. In this expression, so 3 into 6 is 18. 18 minus 2 is obviously 16. We derive 16 to left hand side. Capital A in bracket 3 plus 1 is 4. 4a. Plus capital B, 3 minus 3 gives zeros. That's why B is cancelled. So we remain the only one term 4a is equal this side 16. So 4 goes to this side. 16 upon 4 is 4. So 4 is equal to a. So we derive the value of a is equal to 4. We derive the value of b is equal to 2. In this equation, so we derive 4 upon x minus 3 plus 2 upon x plus 1. So final answer is 6x minus 2 upon x minus 3 into x plus 1 equal to 4 upon x minus 3 plus 2 upon x plus 1. Now we have to resolve the partial fraction in this method, but quite different example is there. What is you look in a denominator? Denominator x square minus x is there. Both the term have x. So how it is possible to solve in a linear factor? Yes, we have to take x common in denominator. That means we rewrite the equation x plus 5 upon x square minus x equal to x plus 5. Numerator remain as the same. We have to take the x common. So x minus 1 is remaining. So x and x minus 1 also factors. So the denominator consists of distinct linear factors. That's why we have to take x plus 5 upon x into x minus 1 equal to capital A upon first factor is x only. So capital A upon x plus capital B upon second factor x minus 1. We have to take the cross multiplication. Capital A into x minus 1 plus capital B into x upon x into x minus 1. These term and this term have the same denominator, that will get cancelled. So what is remaining? X plus 5 is equal to capital A into x minus 1 plus capital B into x. That is true for all x belongs to R. Now first factor is x equal to 0. So instead of x in this equation, we have to put the 0. So 0 plus 5 is equal to capital A 0 minus 1. 0 minus 1 give value minus 1. So minus 1 into A plus 0 into B. 0 into anything is 0. That's why we derive the 0 here. So 5 remain as the same. Minus 1 into A minus A. So minus goes to this side. So minus 5. That's why capital A is equal to minus 5. Now second factor is x minus 1. We have to put x minus 1 equal to 0. That means x equal to 1. So 1 plus 5 is equal to capital A. 1 minus 1 0. 0 into anything is 0. So we derive the here first term is 0. B into 1 is B. So we derive 1 plus 5 is 6 and 1 into B is B. So 6 equal to B. That means B is equal to 6. Now we have to put the value of A is equal, minus A is equal to 5 and B is equal to 6 in this given x plus 5 upon x minus 1. So we derive the final minus 5 upon x plus 6 upon x minus 1. Now we have to take the x plus 5 upon x square minus x equal to. We take suppose x minus 1 first, 6 upon x minus 1 minus 5 upon x. So we derive the value of capital A and capital B in this expression. In this example, we have x square minus x, not linear factors. That's why we have to take x common. So we define x into x minus 1. We split up a upon x plus b upon x minus 1. We put first value is, we have to take cross multiplication, denominator cancel. We get the expression x plus 5 is equal to capital A into x minus 1 plus capital B into x. We have to put x equal to 0. That's why we derive the value of A is equal to minus 5. Then x equal to 1, we derive the value of B is equal to 6. So final answer, we derive minus 5 upon x plus 6 upon x minus 1. You may also write 6 upon x minus 1 minus 5 upon x. Oh, first term is positive, that's why we have to split up, not matter. Final answer you write this way and this way also, both answers are right to be considerable. Simple quadratic factors. Case number 2. Consider the rational function of type px upon qx, degree p less than degree q. Assume the denominator qx has quadratic factor ax square plus bx plus c. The quadratic factor ax square plus bx plus c denominator leads to term the type ax plus b upon ax square plus bx plus c into partial decomposition. That means degree of this numerator is less than degree of denominator. Then quadratic equation is possible. How we have to resolve? Let us take the quadratic equation. Resolve into partial fraction x upon x square plus x minus 2. It is asked in a summer 2013 paper. F of x is equal to x upon x square plus x minus 2. It is quadratic equation. Yes, x have less degree than x square. That's why quadratic equation have factor. Let us check. 2 ones are 2. We need plus 2 minus 1. So we derive the factor x upon x plus 2 into x minus 1. Now note that denominator consists of distinct linear factor. Yes, right. These two factors are distinct, means different. So we have to write now x upon x plus 2 into x minus 1 is equal to a upon x plus 2 plus capital B upon x minus 1. We take the cross multiplication. So a into x minus 1 plus b into x plus 2 upon x plus 2 x minus 1, and these term remain same. So we multiply both side by x plus 2 x minus 1. That means multiply numerator and denominator. These will all get cancelled. We derive answer is only numerator. What? X here is remaining. Capital A into x minus 1 plus capital B into x plus 2. Which belongs to all x belongs to R. Now it is our equation. First factor is x plus 2 is equal to 0. That means x equal to minus 2. So instead of x, we have to put this equation as a minus 2. So minus 2, capital A, minus 2 minus 1 plus capital B, minus 2 plus 2 is 0. 0 into anything is 0. So we derive minus 2, a in bracket minus 2 minus 1. We know that minus 2 minus 1 is minus 3. So minus 3a is equal to minus 2. So minus 3 goes this side. So capital A is equal to 2 upon 3. Minus minus get cancel. Now x minus 1 equal to 0. That means x equal to 1. So in this expression we have to put x equal to 1. So 1 is equal to capital A 1 minus 1 is 0. So a into 0 is 0. So x is remaining as a 1. Capital B 1 plus 2 is 3. So capital B 1 plus 2. 1 is equal to 3b. Yes, right? 3 goes this side, 1 upon 3. So b is equal to 1 upon 3. So we have to put the value of a and b in this equation. A upon x plus 2 plus b upon x minus 1. We derive this equation as a final form. X upon x plus 2 into x minus 1 is equal to 2 upon 3 x plus 2 plus 1 upon 3 x minus 1. If we take 1 upon 3 common, then what is remaining? 2 upon x plus 2 plus 1 upon x minus 1. This is the required partial fraction. So, now we have to take the different quadratic equation. Let us check. Resolve the partial fraction 2x plus 3 upon x square minus 2x minus 3. So, we have to check that this quadratic equation have eigenfactor. Yes, 3 ones are 3. So, minus 3 plus 1 gives minus 2. Yes, right. So, our factor are x minus 3 and x plus 1. So, f of x is equal to 2x plus 3 upon x square minus 2x minus 3. So, 2x plus 3, this quadratic equation have factor minus 3 and plus 1. So, x minus 3 and x plus 1. So, 2x plus 3 upon x minus 3 and x plus 1. Yes, right. So, capital A upon distinct factor. That means these factors are not same. So, capital A upon x minus 3 plus capital B upon x plus 1. We have to take the cross multiplication. We derive a x plus 1 plus capital B into x minus 3. Denominator x minus 3 into x plus 1. These remain as the same. This term remain as the same. Multiply both sides by x minus 3 x plus 1. We only derive the numerator. So after simplification we get 2x plus 3 is equal to capital A into x plus 1 plus capital B into x minus 3. So first factor is x minus 3 is equal to 0. So we have to put x equal to 3. So 3 into 2, 6 plus 3. Capital A, 3 plus 1. B into 3 minus 3, 0. So B is 0. So capital A, 3 plus 1 is 4. A, 6 plus 3 is 9. So capital A is equal to 9 upon 4. Now x equal to minus 1 we have to put. So minus 2 plus 3 is equal to B minus 1 minus 3. So we have to put this expression by minus 1 there. So 2 into minus 1 it is minus 2 plus 3 and A into minus 1 plus 1 is 0 and B minus 1 minus 3 gives the value. So we derive minus 2 plus 3 is equal to B minus 1 minus 3. Minus 1 minus 3 is equal to minus 4B is equal to 1. So B is equal to minus 1 upon 4. We have to put 2x plus 3 upon x minus 3 into x plus 1. So capital A is 9 upon 4 upon x minus 3. Capital B 1 upon 4 into x plus 1. So we take the 1 upon 4 outside. So we derive 9 upon x minus 3 minus 1 upon x plus 1. These are the partial fraction derived answers. Now, example for practice. Write the partial fraction in decomposition. X plus 5 upon x square plus x minus 2. 2 ones are 2. So factors are obviously x minus 1, x plus 2. We have to take the cross multiplication. So we derive the expression. Now in this method we have to take the cross multiplication. Ax plus 2a xb minus b is equal to x plus 5 is remaining numerator. So we have to take the ax plus bx is a plus b into x. Now we have to take the 2a minus b x plus 5. We compare x and x. So a plus b is equal to 1. 2a minus b is equal to 5. We solve this equation. We have to derive a is equal to 2 and b is equal to minus 1 by simultaneous equation. The lecture is over by this expression.